Good day! We are Group 1 and we are here to present an all-encompassing oral report on the crucial topic of measurement standards in inorganic chemistry. The significance of accurate measurements cannot be overstated in our pursuit of scientific precision and dependable outcomes. Our presentation seeks to shed light on the importance of measurement standards, the methodologies employed to ensure exactness, and the extensive implications of our efforts within the sphere of inorganic chemistry. We invite you to join us as we present to you our topics to be discussed. To give a quick overview about our components, we have the objectives, introduction, methodology, results, conclusion, and the recommendations. Objectives. So for our objectives, after performing the experiment, we are expected to measure length, volume, mass, density, and temperature. We are also expected to convert units from metric system to English system and vice versa, and to be knowledgeable about appropriate apparatuses and devices to make accurate measurements.
Measurement standards in chemistry are universally accepted reference points used for comparing measurements. They ensure consistency, accuracy, and reproducibility in experimental results. These standards serve as a benchmark for calibration and evaluation. They often involve unchanging fundamental constants like Avogadro's number or the speed of light, forming the basis for measurement systems. The International System of Units relies on these standards for various physical quantities, ensuring consistency across scientific fields. Essentially, measurement standards offer a stable reference for precise and comparable experimental data.
The uncertainty of measurement can be attributed to A. The limitation inherent in the construction of the measuring device, B. The condition under which measurement is made, and C. The different ways in which a person uses or reads the instruments. Accurate and precise scientific measurements are essential. Precision indicates the consistency of measurements obtained through duplication under similar conditions. This reflects the reproducibility of measurements and is quantified through deviation, either absolute or relative. Absolute deviation pertains to the difference between a single measurement and the average of multiple measurements conducted under similar conditions, while relative deviation represents the ratio of the standard deviation to the mean, expressed as a percentage. Accuracy concerns the alignment between the measured value and the accepted value, often depicted as the percentage error. Typical measurements carried out in chemistry laboratories experiments encompass mass, volume, and temperature. Proper instruments and equipment are employed for conducting these measurements.
Laboratory balances are precise instruments used to measure the mass of objects or substances with a high degree of accuracy. They are designed to provide accurate measurements for various applications in laboratory settings, especially in scientific research, quality control, and analytical chemistry. The accuracy and precision of laboratory balances are crucial for obtaining reliable experimental results, ensuring that substances are measured with utmost precision, even in minute quantities. These instruments are often calibrated regularly to maintain their accuracy and are used for tasks ranging from measuring reagents for experiments to preparing samples for analysis in research and industrial laboratories.
Graduated cylinders are elongated, cylindrical receptacles featuring edge markings on their sides. They serve the purpose of swiftly transferring a reasonably precise liquid volume from one container to another. These cylinders gauge volumes by the vertical extent of a liquid column within them. The volume corresponds to the point on the graduated scale aligning with the lower curvature of the liquid surface, known as the meniscus. Graduated cylinders, a type of cylindrical laboratory glassware, find common application in quantifying liquid volumes. They display marked deviations along their length, denoting measurements of volume. Typically, these measurements are standardized in millimeters or cubic centimeters.
In laboratory settings, thermometers are instruments used to measure temperature accurately. They play a crucial role in various scientific experiments, research, and industrial processes where temperature control and monitoring are essential. Thermometers function based on the principle that temperature causes materials to expand or contract in a predictable manner. Methodology. Preparation of materials. The materials that will be used in this experiment are composed of ruler, test tube, glass rod, 100 ml graduated cylinder, 10 pieces 1 peso coins, 3 100 ml of beakers, triple beam balance, hot plate, thermometer, laboratory manual, and lastly, 150 ml beaker.
So, for the measurement of the length, measurements were taken using a ruler in inches for various objects, including a test tube, a glass rod, and the laboratory manual's length and width. The measured values were converted to centimeters for uniformity in units. The area of the laboratory manual was calculated in squared centimeter based on the length and the weight measurements. So for the calculation, in converting the length of the test tube in centimeter, we need to know first the equivalent of 1 inch in centimeter. The information shows that 1 inch is equal to 2.54 centimeter. Using this, given that a test tube length is 5.9 inches, we multiply it to 2.54 over 1 inch. Then, cancelled out the inches. We multiply 5.9 to 2.54, resulting to 14.99 centimeters. The same method was carried out in the following letter B, C, and D. However, the area of laboratory manual in squared centimeter was calculated differently. The formula used was area equals to length multiplied to width. Specifically, 26.16 is multiplied to 20.57 centimeters, showing a result of 500.11 squared centimeters.
Measurement of volume. A test tube was filled to the brim with water and the volume was measured and recorded using a graduated cylinder. This procedure was repeated, transferring water from the test tube to a 100 ml beaker and then measuring the volume from the beaker. The graduations on a 150 ml beaker were examined and its volume was verified by transferring water to a graduated cylinder. In this experiment, we conducted the volume measurement procedure using various laboratory glassware. Initially, we filled the test tube completely with water and recorded its volume using a graduated cylinder. Next, we repeated the procedure by transferring the water from the test tube to a 100 ml beaker and measuring the volume using the graduated cylinder. To ensure the accuracy of our measurements, we also examined the graduations on a 150 ml beaker and confirm its volume by transferring the water to a graduated cylinder. This indicates a comprehensive effort to verify and cross-validate their volume measurements through multiple steps and different pieces of lab equipment.
Measurement of mass. The mass of 3 100 ml beakers was determined individually using a triple beam balance. Data was recorded in a mass measurement table, and the average weight of the beakers was calculated. Deviation of each beaker's weight from the average were calculated. After recording the data of 3 100 ml beakers, now when getting the average of mass of the 3 100 ml beakers, just add to each other the value of each beaker to get the equal and record it. Getting the sum of the deviation minus the calculated average mass to each value of recorded deviation to get the equal and record it.
So now let's get the measurement of density of the coin column. So we did the experiment and we stacked up 10 pieces of 1 peso coins and we obtained the measurements for mass, diameter, and the height of it. So we got our mass of the column 57.55 grams, height of the column 20 centimeters. The diameter of the column is 22 centimeters, so we got 11 centimeters as our radius. So after that, we will calculate the volume of the coin column since we have all the given that needed in the formula of getting the volume, which is volume is equals to pi times radius squared times height. So let's substitute all the given and we will have volume is equals to pi times 11 centimeters squared times 20 centimeter. Calculate it and you will get 7,598.8 cubic centimeter as our volume. Next, we have our volume and the mass of the coin column, so now we will calculate the density. Using the formula, density is equals to mass over volume. Let's substitute the given and we will have density is equals to mass, which is 57.55 grams, over the volume 7,598.8 cubic centimeter. Calculate it and we will get 0.0076 as our density and our final answer.
So, for the measurement of the temperature, a beaker filled halfway with water was set up on a hot plate. The boiling point of water was heated and recorded in Celsius. The measurement was converted to Fahrenheit and Kelvin. And care was taken to ensure the thermometer's mercury bulb was submerged in water and not in contact with the beaker's walls during the temperature measurement. So for the explanation, in calculating the temperature of boiling water in degrees Celsius, Fahrenheit, and Kelvin, first and foremost, we use the recorded boiling point of water in Celsius, which is 95 degrees Celsius. Converting it to Fahrenheit, the formula was 95 degrees Celsius multiplied by 9/5 and added to 32. In which we calculate a total of 203 Fahrenheit. Moving on to the next part, which is the calculation of Kelvin, we use a different formula that can be explained like this. 95 degrees Celsius added to 273.15, the result was 368.15 Kelvin. In summary, the boiling point of water in degrees Celsius is 95 degrees, while in Fahrenheit it is 203 and 368.15 in Kelvin. So for the results of the measurement of length, in measurement of length, the results we calculated are the following. The length of the test tube is recorded as 5.9 in inches and 14.99 in centimeters. The glass rod, on the other hand, has 11.8 inches and 29.97 in centimeters, while the length of the lab manual is 10.3 inches and 26.16 in centimeter. Lastly is the width of the lab manual that is 8.1 inches and 20.57 in centimeters.
The volume of water in a test tube is 25 ml. Then the water is transferred in a 100 ml beaker resulted to the volume of the water measuring 25 ml. The volume of water in a 150 ml beaker is 29 ml, measured with a graduated cylinder, to ensure the accuracy and reliability of volume measurements. Overall, the experiment showcased a systematic approach to ensure the accuracy and reliability of volume measurements. The researchers utilized different pieces of laboratory glassware, test tube, beakers, and graduated cylinders, and employed multiple steps to verify their measurements. This multi-step process minimized errors and discrepancies in volume measurements, contributing to the overall validity of the experimental results. Which measuring apparatus for the volume of liquid is the most appropriate to use for accuracy? A graduated cylinder is the most suitable measuring instrument for precise liquid volume measurements because of its graduated markings, excellent precision, versatility, ease for reading, and relatively minimal meniscus error. How many significant figures does a measured volume have? The volume of the water in a test tube is 25 ml and has two significant numbers, while the volume of water in 100 ml beaker is 25 ml that also has two significant numbers. The volume of water in a 100 ml beaker is 29 ml that is also measured in a graduated cylinder has two significant numbers. When a glass has a marked capacity of 100 ml, does it need to be filled to the brim? The labeled capacity represents the highest volume the glass can accommodate, but is not recommended to fill it to the brim due to various reasons, to ensure safety and prevent potential problem caused by overfilling.
We have seen the result in our measurements that there are different masses of the beakers because of each different weight, length, and number of ml that can be measured.
So now let's get the measurement of density of the coin column. So we did the experiment and we stacked up 10 pieces of 1 peso coins and we obtained the measurements for mass, diameter, and the height of it. So we got our mass of the column 57.55 grams, height of the column 20 centimeters. The diameter of the column is 22 centimeters, so we got 11 centimeters as our radius. So after that, we will calculate the volume of the coin column since we have all the given that needed in the formula of getting the volume, which is volume is equals to pi times radius squared times height. So let's substitute all the given and we will have volume is equals to pi times 11 centimeters squared times 20 centimeter. Calculate it and you will get 7,598.8 cubic centimeter as our volume. Next, we have our volume and the mass of the coin column, so now we will calculate the density. Using the formula, density is equals to mass over volume. Let's substitute the given and we will have density is equals to mass, which is 57.55 grams, over the volume 7,598.8 cubic centimeter. Calculate it and we will get 0.0076 as our density and our final answer.
So for the results of the measurement of temperature, in the measurement of the temperature, we calculated that the boiling point of water in degrees Celsius is 95 degrees, while in Fahrenheit it is 203 degrees Fahrenheit and 368.15 in Kelvin. So for the question part, Why must the mercury bulb of thermometer not touch the wall of the beaker when measuring the temperature of a liquid that is being heated? So to answer that, to obtain pressure temperature readings when measuring a heated liquid, it is important to keep the measuring bulb of the thermometer away from the beaker's wall because touching the wall can cause inaccurate reading due to heat transfer, delayed response time, unseen heat distribution, and variations in the beaker's surface temperature. So for dependable measurements, fully submerge the thermometer's bulb in the liquid to directly reflect its temperature without interference. The practice is critical for acquiring temperature data during experiments and ensuring precise temperature control in laboratory procedures.
In summary, the laboratory procedure involved various measurements, including length, volume, mass and density, and temperature. Accurate techniques were used to ensure reliable data collection, and calculations were performed to derive valuable information from the measurement.
Safety considerations. Ensure that safety measures are integrated into measurement procedures. Safety is paramount in any laboratory setting, and safety breaches can affect measurement accuracy. Use of certified reference materials. Whenever possible, use certified reference materials that have known and well-established properties. These materials can serve as benchmarks for accuracy and can help validate measurement methods. Record keeping. Establish a robust record-keeping system to document all measurements, calibration procedures, and instrument maintenance. This documentation is essential for quality control and traceability. By adhering to these recommendations, inorganic chemistry laboratories can maintain high measurement standards, improve the reliability of their data, and contribute to the advancement of scientific knowledge in their field.